Imagine that you and your family are living like this. This is a photo of a family on the outskirts of the world's largest refugee camp, a notorious camp called Dadaab. They are collecting firewood. They need food. They need help. They need water. Imagine machines that can extract water from the atmosphere, extracting all the water that this family needs, all the water this region needs. Dadaab is in Kenya. It was constructed in the early 1990s. It was only intended to be temporary. Most of its 500,000 refugees are from Somalia and Ethiopia. I live in Minnesota, a land of 10,000 lakes. This year, even with the hot, dry conditions, Minnesota is growing a bumper corn crop. In this photo from the same refugee camp, we see a young girl standing amid the graves of 70 other children. More information about these two Oxfam photos can be found at Wikipedia. Aid will help these people. I recommend that people give generously to assist the charities that help the victims of Africa's famines. However, to enable these people to survive on their own, this region needs water. Imagine machines that can transform this desert from brown to green. Imagine transforming 2 million square miles of African desert into farmland. When I was in Boy Scouts, most of my merit badges involved water. I love water. Many of my hobbies involve water. Swimming, snorkeling, scuba diving, canoeing, rowing, sailing, fishing, water skiing. Here, in another part of Africa, a giant dust storm is engulfing a distant village. Again, all over the world, massive amounts of water is needed. Imagine machines that can obtain enough water to irrigate desert grasses. This would transform the world's environment. One of my hobbies is looking for agates along the north shore of Lake Superior. Lake Superior has a surface area of about 31,700 square miles. It contains about 2,900 cubic miles of water. The massive droughts around the world not only affects people, these droughts also are affecting the animals. In this photo, a family of elephants has found water. Now they're off to find food. Notice what the drought has done to the trees in the background. In this situation, there might be some water to drink. However, obviously, the food is scarce. The entire Sahara and Sub-Sahara region needs water. Imagine over 1 million square miles of the Sahara Desert being transformed back into savanna. Imagine how the great animals of Africa would be helped. One of my favorite locations is St. Anthony Falls. It's where Minneapolis was started, on the banks of the Mississippi River. This area is famous for the river, for the falls, for its many restaurants, for its grain mills, for its giant grain silos, and for giant food companies. Right now, in countries like Somalia, Ethiopia, Kenya, South Sudan, Sudan, Chad, Niger, and Nigeria, there are severe drought conditions. In recent years, in these and in many other countries around the world, millions of people have died from famines. Huge numbers of people will soon die if the drought conditions are allowed to continue. Yes, lives can be saved by shipping food, water, and other aid. However, that will not reverse the drought conditions. That will not solve the underlying problem. This new physics clarifies many things. The real long-term solution is described in the last part of this film. We don't want to just provide aid. We want to transform the environment. We want to collect massive amounts of water and grow massive amounts of plants. Life is full of dramatic contrasts. Personally, I am surrounded by water. For me, it is easy to see water. Every day, it is easy for me to obtain water. I see water everywhere. Not everybody gets to live in a land of 10,000 lakes. In hot deserts all over the world, people, animals, and plants are dying. They too are surrounded by water. In stark contrast, their water is not easy to see. They are surrounded by water in the atmosphere. With this new technology and with new energy, that atmospheric reservoir of water can now be tapped into. We can drain water from the skies. We can do this now, even without fusion energy. Right now, we can start transforming sterile deserts into lush green lands. For me, this all started about 34 years ago. Right now, this time in 2012, I am 51 years old. In the summer of 1977, when I was about 15 or 16, after I read a book about black holes, I wondered, what happens to an elementary particle's energy as the particle passes through the event horizon of a black hole? It was a classic physics thought experiment. For months, I thought about this all of the time. Quickly, I realized this question did not really need to involve black holes. The focus of my question became more general. What happens at the moment when elementary particles transform into energy? As a physicist, it really does not matter if you agree or disagree with black hole theory. You still need to understand this is one of the central questions of physics. Every physicist needs to be able to clearly understand and visualize exactly how this transformation takes place. How does matter transform into energy? And how does energy transform into matter? That simple thought experiment that I did as a teen later helped me to unify physics. In my youth, I had other influences. Back in the 1970s, there was a major energy crisis. I read a lot about the future of energy. Back then, a hot topic was fusion energy. Fusion energy intrigued me immensely. In high school, I even had a subscription to a magazine called Fusion. In my senior year of high school, I took my first physics class. It was in the spring of 1979. I was 17. Unlike everyone else in my class, I was really looking forward to learning about physics. I had a number of specific questions that I wanted answers to. My biggest question was, what is time? I really wanted someone to answer that question for me. I did not imagine that 4 years later, I would be the person to solve the mystery of time. When I did, I was so surprised. At the time, I was especially looking forward to learning about Einstein's relativity because I was under the impression it would explain time. Unfortunately, it did not. When you study relativity, you learn this. As you approach the speed of light, time slows down. When I first heard this in my high school physics class, I immediately raised my hand. I said to the teacher something like, that can't be true. That has to be wrong. My high school physics teacher said something like, all physicists believe this, and if you don't, you'll have to prove it. So I did. That was a turning point in my life. At that moment, I knew there was something very wrong in physics, and that this huge problem in physics dealt with time. As it turns out, in a couple of ways, I was right. First, it was a problem with time. Second, this can't be true, because this is inherently illogical. Using extremely simple logic, it is easy to show why time cannot speed up and slow down. This is easy to prove because it is an obvious circular definition. Physicists started out here by defining time and length. Then, using these two ideas, they define the concept of velocity. Keep in mind, the concept of velocity derives its meaning from the definitions of time and length. Then, in relativity, time and length are redefined in terms of velocity. That is all it takes. It is that simple to prove. If velocity is defined using time, then time cannot be a function of velocity. Time cannot be redefined using velocity. This is illogical because this is a circular definition. Keep in mind, this logic has no influence on what is physically happening. This is logical, not physical. Circular definitions are inherently illogical. This logic only highlighted for me that there was something wrong with our explanation of physics. Initially, my realization did not point out for me what the problem was. However, I could tell the problem involved time. Remember that feeling you get when you have forgotten a word? It is kind of like a sensation. People often describe the sensation like this. It's on the tip of my tongue. They know the word. They just can't remember it. That is what it was like for me back then when I was a teenager. I felt like I had this big idea, like it was on the tip of my tongue, like it was on the edge of my mind, and it had something to do with time. It was kind of weird. It was an always present and strong sensation. That sensation stayed with me for 4 years. I invite you to imagine what that would have been like for you. It was in 1979. I was 17 and I had this huge conflict. On the one hand, I was extremely bothered by the fact that relativity had an obvious logical error at its core. On the other hand, I knew relativity was successfully being used to make some types of physical predictions. Yes, there truly was something physical happening that relativity was describing. On the other hand, relativity was fundamentally illogical. On the other hand, somehow, this physics also worked. In other words, nature really had something important going on here. It was just that the physics was not yet describing it logically. What I failed to grasp in high school was this logical problem has been barricading the advancement of physics since the 1920s. Right now, the physicists that are stuck at the end of the corridor in the physics maze think they're trying to break down a wall called superstrings. Actually, the wall before them is called time. That is why they have been unable to break it down. As I studied physics, the question, what is time, was constantly on my mind. In college, roughly 4 years later, specifically on March 23, 1983, it suddenly clicked. I solved the central problem. On that day, I solved the mystery of time. This is what I visualized on that day. In my opinion, every person of science really must understand this. Here's an animation of that idea.